mentioned that the electric motor is 4 or 5 times as efficient as the internal combustion engine. So that means that you have not 60 times as much energy, but about 12 times in effect. Okay, and then it's not. I mean, you can improve internal combustion engines, but there's not really much scope for improvement. But there's potentially quite a bit of scope for improving batteries. But the received wisdom about batteries is that you could double their present performance, but tripling it is dreaming. Okay? But let's dream. Okay? Let's triple that, which means that it comes down to 4 times as much. Still 4 times as much energy in the gas tank as in the battery, which means 4, at the best possible thing, 4 times as much range, or put it the other way around, 1/4 as much range on the battery. And that's just the range, and that's a huge issue. There is a big problem among electric vehicle manufacturers called, or big opportunity, sorry, called range anxiety. Okay, and that, you know, we've got to deal with this opportunity of range anxiety. So, one way around all of this is to not do either of the 2 things that I have suggested so far, which is have a battery or feed it from the grid. The other thing you can do is put a generator of electricity on the vehicle itself. And the ones that you hear most about are fuel cells, which I'm just going to come to, and internal combustion engines, which is what you have in a hybrid vehicle, where you have an internal combustion engine that makes electricity that drives the wheels. And that can make sense, but you're still using a fair amount of fuel. Let's just look at the fuel cell one, which was a real red herring that preoccupied people for years and years and years. And now it's mostly, but not entirely, forgotten about. Let's just look at the energy dynamics of fuel cells. So we take a wind turbine on the left at the top, and the idea is that the wind turbine produces electricity, but instead of running the electricity to the vehicle, which is on the bottom and I'm going to come to, for a fuel cell you have to turn it into hydrogen, because hydrogen is the fuel for a fuel cell. And you can do this by electrolysis. It's pretty easy. It's been known for 200 years how to do that. But the energy loss is about 50%, turning electricity into hydrogen. And then you put the hydrogen in the fuel cell, and you've got another 50% energy. Fuel cells are about 50% efficient. And you've got another 50% energy loss. And what you have to do is multiply those 2 together to get the total energy loss. And then if you liquefy the hydrogen, you have to add another 5%, because that takes energy as well. And sometimes they want the energy liquefied, the hydrogen liquefied for transportation. So you finish up with the energy loss from the turbine to the fuel cell car of 75 or 80%. Compare that with something that happens in real life in the city of Calgary, the oil capital of Canada, where they have wind turbines in the foothills of the Rockies, which are entirely fueling Calgary's light rail system. Okay? And the slogan on Calgary's light rail system is "Ride the Wind." It is an entirely wind-powered light rail system. The only one in the world. There's another one being built in New Zealand. What is the energy loss from the turbine to the Calgary LRT train? It is 10%. And when you get some good Chinese technology coming in there, it will go down to 5%, but presently it's 10%. Chinese are leaders in grid transmission of electricity. And in an energy-constrained world, comparing a 10% loss, or even better 5%, with 75%, is no competition. So that's why people are losing interest in fuel cells. But it doesn't mean that they are getting interest in the other thing, which is grid connection, because there are problems with grid connection. You need to be grid connected. Where do batteries come in? Well, when you put energy into a battery, you lose about 20%. And when you pull it out of the battery, you lose about 20%. You can improve on that, but probably not more than 15%. So it's somewhere in between. You know, you've got, say, 60 to 70% fuel loss on the battery, 30 to 40% fuel loss on the battery, 10% on the grid connection, and 75-80% on the fuel cell. So we need to electrify, and we need to have grid connection where we can. And just yesterday, there's encouraging news from Go Transit. I mean, they're not going to buy electric trains for the airport line straight away, but they are dealing with electrification, and the preliminary findings are that electric locomotives are the most cost-effective. It's got an ongoing study, and they have narrowed their zillion options down to 6. And one of the 6 options is electrifying the whole system. In the UK, they have lagged a bit in electrification compared with the rest of Europe, or the rest of Western Europe. And they did a major study last year on catching up on electrification in the UK. And they discovered, this is the regular rail lines, this is not the regional lines in the city, this is the intercity lines. And they discovered to their astonishment that if they took a 35-year time frame, they would actually save money by electrification. It would actually, because the trains are lighter, there's less track wear, the trains require less maintenance and less energy, it would all offset continuing with their mostly diesel arrangements. And they didn't go into that thinking that that would be the outcome. Encouraging news from Quebec. This was in this week in La Presse or somewhere, a monorail between Quebec City and Montreal. My principal client at the moment is the government of Quebec, and looking at forward transportation, and this and several other things are very much on the agenda, but I didn't know it was going to be in the paper. This should be a photograph of the Disney World monorail. I don't know what happened to it. Maybe it's, there it is. Built by Bombardier. Not the track, but the trains. Trains of Bombardier trains. Another monorail in Wuppertal, the granddaddy of monorails, been in operation since 1898. The trains are relatively new, but the structure is the original, more than 100-year-old structure. Monorail is another form of grid-connected transportation. And there are many others, you know, maglev and so on. Trolley trucks. This is a truck in a Canadian mine in Nevada, gold mine, made by Siemens, German company. Trolley trucks have been used extensively in Canada, and there's a wonderful study done of an iron ore mine in Quebec, which is now closed. But in the 70s, when they had the oil scare, they were really worried about the amount of diesel fuel they were using. In, you know, these mines, they go down very deep, and they have these roads that wind up, and they're pulling up the ore right to the top. And somebody had the bright idea of saying, well, let's electrify these trucks. Problem, there is no electricity. So they put a massive diesel generator there, made electricity, put wires up just like this, and put in electric trucks, and the energy saving was 80%. They used 80% less diesel fuel to do it that way than having the diesel. Now this is optimum for a truck, because for an electric vehicle, because an electric vehicle has its maximum torque at 0 speed, or just above 0, and when it is climbing very slowly, whereas a diesel motor has its maximum torque when it's doing about 2,000 or 3,000 revolutions a minute, and it's not optimized, can't be optimized for that truck situation. So you will often see trolley trucks in mines and in forests, and they give you some idea of the possibility. Could we have these on roads? Well, they did in the former Soviet Union in one place, although it's problematic. But the wires up there are essentially the same wires as trolley buses use and trolley buses work. We have to deal with this car issue. This looks at the City of Toronto, and for the last year we have good data, 2006, and looks at how people move around in the City of Toronto. Remember I mentioned Hong Kong, 80% transit, 10% cab, and 10% car. Here the cab is wrapped up in the transit, and there's much less than 10%. So the top two are roughly the old City of Toronto, York and East York. It's actually the Central 6 Metro Planning Districts, but that's just how they do the data. And the bottom two are roughly the Etobicoke, North York and Scarborough, those old suburbs. Pretty close, not identical. And the left two are rush hours, periods, and the right two are other hours. And you can see that even in the core, during rush hour periods, the car prevails. 52% of all journeys are made by car. This is not kilometers, this is just numbers of trips. And, as you move out or move away from the core, you see even more car use and less transit use, and there are interesting things happening with cycling and walking in some places. But the car prevails. I mean, you don't really need those charts to show it, but you just have to remember, with all this talk about Transit City and everything else, that the real issue is how you deal with the car. And the real issue I am trying to grapple with more and more is how you grid connect cars. But let's have a digression about congestion, okay? Because
or gridlock.
Yeah, but gridlock, whatever you like. I mean, there's a huge amount of gumph talked about congestion. Really, it is extraordinary. I mean, people are literally pulling numbers out of the air, and if you try and trace anything, it goes back to nothing or vagueness. But what I did do was look at how two writers in the Globe and Mail, one in the main part of the newspaper, one in the car, on Fridays they have a car part of the newspaper, dealt with a very good survey that was international survey that was done by IBM in May, and included 5 North American cities, and the top 2 bullets are what each of these reporters wrote. One said 5 North American cities were polled, and Toronto, surprise, topped the list of the most unhappy customers. And then the other one said Torontonians are more aggravated by their daily commute than the residents of New York, Los Angeles, or Montreal. I forget what the 5th city was. But what did the survey actually show? I went and looked at the data coming out of the survey. What it showed was that in the Toronto region, this is not just the City of Toronto, 2/3 of people have a commute of less than 30 minutes. 2/3 of people. It wasn't quite the lowest, but it was almost the lowest. Only 4% are over 45 minutes. And you only get to thinking you have an unreasonable commute when it's over 45 minutes. This is one way, of course. People in Toronto left for work later than any of the other cities that were North American cities. They were less inclined to switch to transit when fuel prices went up. If congestion were a problem, they might be more inclined to switch to transit. And they were less inclined, not more inclined, but less inclined to report travel stress than people in Toronto, in Montreal and Los Angeles. Whereas person who said they were more inclined. It's just a flat lie. Just a flat lie. This wasn't in the survey. So I went to the real expert on these surveys, and I said, what goes on in congestion surveys? I haven't pursued this fabrication of the cost of congestion, but I talked to her, a woman in London, and she said,